Okay, here is another videos because I find a very useful software which called PowerPoint。原來 PowerPoint 就自帶錄音同錄影功能，總之我尋日唔使咁辛苦啦。好啦，咁我而家就好快咁同大家 go through 一下呢個 PowerPoint 啦。咁我哋學緊呢個 uniform circular motion。So what is uniform circular motion? The linear speed, not velocity. Okay, so because the directions of the circular motion is keep changing, so the velocity is changing, but the linear speed doesn't change. Okay, so the magnitude of the velocity doesn't change, and the angle of velocity doesn't change. For this kind of motion, then we call this the circular motion. Okay, so circular motion equals to something moving in circles. Okay, so which is and then radian. So I've asked Mr. So that you have already learned about the radian and the arc length, and I skip this part. Okay, so and I have told you in my last videos. Okay, so I will skip. Okay, so for describing the circular motion, then we need to use the terms which we call the angular displacement. Okay, so the change in positions measured in angle. The angular displacement has its direction, okay, so which is clockwise and anti-clockwise, 順時針、逆時針. And then the angular velocity describes how fast an object turns. So it also has the direction. The directions is in this case anti-clockwise. Okay, so if it's rotating into the other direction, then which is clockwise, omega equals to theta over t, which is radian per second. This is the unit for the angular velocity. I will try to speed as fast as possible in this video. Okay, so because some of you may already understand this topic roughly. Okay, so through the video, yes. And then for the period, okay, so like the examples I gave yesterday, period is the times needed for you to complete one thing or for the objects to turn one full revolution. Okay, so if you can eat the hamburger in 2 seconds, then the period for eating a hamburger is 2 seconds. Since omega equals to theta over t, so the angular displacement for one turn is 2 pi. The time is 1 period, so omega can be changed to 2 pi over t. And then so relating the angular and the linear motion. So in a uniform circular motion, the linear speed, okay, speed is a scalar. That means there is no direction. Velocity has its direction, and the angular speed remain constant. Okay, so but the directions of the velocity change continuously because there is acceleration. Okay, so when time equals to 0, then it's at original position. So when time equals to t over 4, then it's complete 1/4 of the circular motion. Okay, so half circular motions, 3 over 4 circular motions. When time equals to t, then it's go back to the original position. Okay, so this is the physical meanings of period. And then, so the angular motion described by the angular displacement. Okay, so the change in angle, the angular velocity, how fast it turns, and the linear motion described by the arc length and the linear velocity. Okay, so the linear motion actually is just talking about the particles moving along the arc. Okay, so the velocity of the particles moving along the arc is called the linear velocity. Okay, so we use the arc length over the time. Okay, so we call that theta equals to arc length over radius, which is s over r. So the displacement equals to r times theta. Okay, so displacement equals to r times theta. And then divide both sides for t. So s over t is linear velocity. Theta over t is angular velocity, which is v equals to r omega. Okay, so this is what I skipped yesterday. Okay, so I tell you it's quite difficult to know how you can get this relation. Okay, so because I don't know, you have already learned how to find arc length. Okay, so now you know that v equals to r omega and omega equals to 2 pi over t. So rearrange the equation, then v equals to 2 pi r over t is actually d over time. Okay, so I will skip it as fast as possible. Okay, so then now we go to something new, what we call the centripetal force. Okay, so in Chinese, which is 向心力 not 離心力 Okay, so 離心力 is a 虛構的力佢唔存在於呢個世界嘅離心力。唔好成日亂咁同人哋講離心力，人哋笑你唔識 physics。OK， 咁我哋講向心力，向心力即係咩意思咧？So imagine a boat moving on a lake at a constant velocity. So if there is a force acting sideways, okay, then it will change its direction. Okay, so if the force moving same to the directions of the velocity, then it will accelerate or decelerate. However, the velocity is now pointing up and the force is pointing sideways, then it will change its directions and have the circular motion. And this is what we call centripetal force. Okay, the boat change its direction but keep moving at the constant speed. In this case, we call this the uniform circular motion. Okay, so if you draw the diagram here, then the linear velocity is the tangent of this circle, and the centripetal force point to the center. And also, since F equals to ma, then the accelerations point to the center. The boat want to go straight forward, but there is accelerations pointing sideways, so this change its direction. And now, so we will see some example. Okay, so actually I have done some example yesterday, but so in this case you have the diagram, then it may be more easier for you to understand. So the minute arm takes 60 minutes to turn through a full circle. So if you don't trust it, then you can count the motions of the minute arms for the clock in your home. Okay, so its period is 60 minutes. So how large is the angular displacement of the minute arm in 20 minutes? So in 20 minutes it rotates 120 degrees, so which is 2 pi over 3 radian. So that's all. And then what's the angular speed? Angular speed equals to theta over t. So theta over t, then you get the angular speed. Okay, so example 2, the Singapore, how to pronounce this word, flyer. So it's approximately turns 2 cycles in an hour. Okay, so each cabin is located at about 150 meters away from the center. Okay, so the radius is 150 meters. Okay, so it's complete 2 cycles in 1 hour. So what is the angular speed? Again, angular speed equals to 2 pi over t, or you can directly use theta over t. So the period, it can rotate 2 turns in 1 hour, right? So the period is 1,800 seconds, and then omega equals to 2 pi over period. Then you get the linear speed. You get the angular speed. And then estimate the linear speed. Linear speed equals to how omega. Oh, I mistake and just go to the second page. Okay, so I think you already know the answer, right? So if the wheels was built larger so that the cabins were further away from the center, how would the angular speed and linear speed change? The angular speed doesn't change. Okay, so because the position won't affect the time it needed to complete one cycle. However, since v equals to r omega, okay, then the linear speed will be changed. So same angular speed and higher linear speed. Oops. And now I will tell you the equations of the centripetal force. Okay, so for the centripetal force, actually there are 3 equations. So F equals to mv squared over r, F equals to mr omega squared, and since omega equals to 2 pi over t, then the centripetal force can be F equals to m r 2 pi over t squared. Okay, so you need to memorize these 3 equations. Okay, so there is a easy way for you to understand. There is a song about the circular motion. 这个歌曲是一个台湾的物理老师写的，不关我的事。不过我就唱一下给大家听。mv 平方除以 r omega 平方 mr 2派平方除以 t 平方，懂不懂啊？再来一次 mv 平方除以 r omega 平方 mr 2派平方除以 t 平方，懂不懂呀？再来一次 mv 平方除以 r omega 平方 mr 2派平方除以 t 平方，懂不懂呀？再来一次。好了。我想现在大家已经记得差不多了吧？你就做作业的时候就一直在背，一直在唱就对了。那现在我们换回英文。Since F equals to ma, right? So F equals to ma. So R 2 pi. Oh, sorry. Here first. So F equals to ma. So V square over R equals to the acceleration. Okay, and so on. F equals to ma. Now we will talk about the properties of the centripetal force. The centripetal force is not a kind of force. It refers to the net force required to produce the centripetal acceleration. Okay, so it's quite weird, right? So what's the meaning of centripetal force? It's not a kind of force. Okay, so first centripetal force is 向心力not 離心力，記住。Okay, it's not a kind of force. So I will give you an example. So if you have a classmate next to you, 唔好成日出街啦 ，OK? So and you pinch your classmate. So the force point to erect the right hand side is 3 Newton. The force point to erect the left hand side is 2 Newton. Then what's the net force? The net force will be 3 minus 2. 隻手跟唔到個腦，好攰。3 minus 2 equals to 1 Newton. Okay, so which point to erect the right hand side? So this 1 Newton is not a real force. Okay, so this 1 Newton is just a net force. So centripetal force has the same concept. It's not a specific force, but the remaining force or the resultant force or the force after calculations or what we call net force. Okay, so it's the effect of combining all the forces. Okay, so I will give you an example directly related to the circular motion now. So I need to erase this weird classmate. Okay, so if I am swinging the ball in clockwise, okay, so here is the center of mass. Not center of mass. Here is the center of the circular motion. So I'm swinging the ball in clockwise. Okay, and what is the force acting on this object? So there is tension, and then there is mg. So what is the centripetal force? So the centripetal force should be point to erect the center, right? So it's moving along the circular motion. So there must be something providing the centripetal force. So the centripetal force is the force point to the center, okay? It's the net force point to the center. So in this case, T minus mg. So centripetal force is not the tension or the weight, but the net force point to erect the center. The net force point to erect the center. The net force point to erect the center is very important. Centripetal force is not a force, but the net force point to erect. So for the object moving in a circular motion, there must be some force provide the centripetal force. Okay, so for example, this car is making a turn, then the friction between the tire and the floor provide the centripetal force. So this one, the tension provide the centripetal force. The normal reactions provide the centripetal force. Okay, so there must be some force provide the centripetal force. If your boyfriend is rotating around you, orbiting you, then your attraction provide the centripetal force. But this is the net force. Okay, 譬如你個男朋友圍住你轉，但係隔離又有個好靚嘅女仔喎，係咪？咁就你嘅 attraction 減咗你嘅男朋友同隔離個女仔嘅 attraction，嗰個先係 centripetal force 啊。好啦，咁咧睇住呢度冇呢個 centripetal force 啊，淨係得 friction 咧 ，friction 就係呢個 centripetal force 啊。好啦，咁所以如果寫翻嗰條式咧，呢個 friction 就等於 mv 平方除以 r。mr omega 平方 mr f i 平方除以 t 平方，懂不懂呀？就是這樣。好啦，今日咧其實純粹想試下呢個功能嘅，如果好咧咁就下星期繼續用。咁咧所以就教多少少就係咁啦，睇下下一版係咩。好，唔講。